All right, we are now recording. So, before we get started with our lesson on today, I just want to give everybody a reminder that the AP exam is scheduled for next week, May the 5th. Um, also, keep in mind that in order to get in the building to take the AP test, everyone in here must have a 2020-2021 identification badge. If you're in need of an identification badge for this year, you're going to have to come up here and get one. Okay, I want everybody to note the times. So, guys, you can come up here anytime this week. That is between 9 a.m. and 11 a.m. or between 1 p.m. and 3 p.m. Okay, so these are the times you come up here this week to get your ID badge. Now, um, um, students are to enter door 1 on Eagle Drive, and when they enter, ask for Security Officer Mr. Roderick, okay, because this is the guy who will be handling the ID badges for you. Everybody got that? So, you will need an ID badge to take the AP exam next week. Now, guys, the physics test is going to be on Wednesday, and it officially starts at noon 12 o'clock. However, everybody needs to be up here at least 1 hour before that because, we have to get settled. We got to get you guys into your testing room, and then we have to read the instructions and everything so that we can start the test. Because the College Board says that we have to start at a very specific time. So everybody be up here basically by 11 o'clock on Wednesday of next week. So everybody got that? So the test starts at noon, but you guys need to be up here an hour before that. Okay? Um, Next Wednesday. Yeah, next Wednesday. Does anybody have any questions for me regarding the AP exam next week? Yes, Jerry. It starts at noon. So that means you need to be up here by 11. Yep, it is getting close. It is coming upon us very, very, very fast. Yes, May 5th, right? Yes, it is May 5th. Um, which means, of course, this is y'all's last weekend to basically look over those videos and stuff through the College Board. Um, are there any immediate, well, are there any more questions for me regarding the AP exam? All right, so guys, let us go ahead and get started. So we are continuing our conversation into momentum. So let me show you guys what is in Schoology. Specifically today, we're going to be analyzing the mathematics of collisions and talk about the two different types of collisions that you can see in this course. Okay, so click on fourth period. Click on materials. Of course, you guys see I put a new folder on this page which says final 6 weeks. And today is April the 26th, last week in April, and it is a Monday. Okay. So as I said, today we're going to talk more about collisions. As you guys can see, I have some notes in Schoology for you guys. And then we're going to do a few problems together on this momentum and collisions assignment. And as soon as you guys get done, take a picture of your work and you're going to upload it to the submission box here. So you guys will need to show your work in order to get full credit. So everybody got that? Now, if I were you guys, I would have some paper so that when I take these notes and give you guys the equations you guys going to need that you guys going to need for today, if I were you, I would write those equations down because you're going to need those equations to do the assignment that we're about to do. So when I write the equations down, be sure to write what I write. Okay. Now, if you remember on last week, I introduced this concept of momentum to you guys. And remember how I define momentum. Momentum is defined as the property of motion. The property of motion. So mathematically, it is the product of an object's mass and its velocity. So remember what I said last week, guys, that momentum is a conserved quantity in any collision. Anytime you have collisions in nature, the total momentum of that collision stays conserved. So what does that mean? When I say total momentum stays conserved, remember what conserved means? Conserved means stays constant or stays the same. So if I take one ball here and I release one ball on one end, notice one ball comes out the other end. So if I take two balls and release two balls on one end, notice two balls comes out the other end. So notice there's a property to motion which stays conserved in this collision. That property is what we know as is what we know as momentum. So even if I take four balls on one end and release it, notice four balls comes out. So the total momentum stays conserved. I can either do that. I can either do it from the opposite end. If I take three balls on this end, release it, notice three balls comes out the other end. So the point is, you guys can see that there's a certain property to motion which stays constant or stays conserved, as is demonstrated from the Newton's cradle. Okay, that property is what is known as momentum. You can think of momentum as being the magnitude of motion, um, or the quantity of motion. Okay, so again, that was something that we talked about last week. Okay. Now, um, in Schoology, I have some notes for you guys. Um, let's pull this up now. Now, guys, in this class, there are two types of collisions that you all need to be aware of. Two types of collisions. The first is what is known as an elastic collision, and the second type is what is known as an inelastic collision. So, what is the difference between the two? What is the difference between an elastic collision and inelastic collision? Well, whenever you have elastic collisions, it turns out objects bounce off each other in elastic collisions, but in elastic collisions, objects stick together. Okay, so that's the important difference that you guys need to know. And of course, an example of an elastic collision is the Newton's cradle. Notice when one ball collides, there's a bounce in the motion, right? There's no sticking that goes on for the elastic collision. However, here's an example of an inelastic collision in nature. Imagine two cars collide and the material becomes mangled and twisted, so that the material causes the cars to stick together. Okay, so this is considered to be an inelastic collision, where the objects stick together or they become mangled and deformed. Okay, um, so it's important that you guys know the difference between the two. And in just a moment, I'm going to give you guys the equation for elastic collisions and the equations for inelastic collisions. Um, Before I do that, I'm going to come over here and I want to show you guys these two types of collisions on a track. Normally, around this time, during a normal school year, we would do a elastic and inelastic collision lab. However, since most of you guys are at home, I'm just going to show you guys how this looks like visually. So I'm going to come over here to this station here. Okay. And, okay, I want to show you guys something real quick. Okay. So, okay, so guys, if you look at the table here, so notice here that I have a track here. And on this track, I have two cars. Okay. So this is mass 1, this is mass 2. So I have two cars. Um, and notice, guys, on one end of the cars, I don't have any Velcro, but I have Velcro on the other end right here. So this is going to allow me to change between elastic collisions and inelastic collisions. So starting out first with the elastic collision. So um, this right here, so that right there that you guys just saw, that's an example of an elastic collision. I'm going to say it again. So that's an elastic collision. Let us compare that to the inelastic case. In the inelastic case, notice I'm a flip the carts around to the Velcro end. Again, cart one, cart two. In other words, mass one, mass two. So this here, that's an example of an inelastic collision. Everybody see the difference between elastic and inelastic? You got that? So, so awesome. So remember, elastic. Notice how one cart bounced off the other. So, um, but for the inelastic, so this is the inelastic. So in the inelastic, they stick together, right? So they stick. Um, there's magnets on this end, and then there's Velcro on this end. But the magnets is not so important as the magnets just help makes the elastic collision more like smoother. So like they just push against each other. Yeah. Yeah, it helps them. It helps us pushing you. It's more smoother, and you don't get that rigid like clinking sound. But the point is, it's just like for the elastic, one bounces off the other, and for the inelastic, they stick. Yeah. Yeah. So, so everybody got that? Now, going back to your notes. So going back to your notes. Um, Guys, here's an excellent way to remember the difference between elastic and elastic. To remember which one is which, guys. This is what I think of. This is what helps me when I look at inelastic. When I see that inelastic, I think of in love. That's what comes to mind. In love, you guys know whenever two people are in love, they're stuck together, right? So, right, if your mom and dad are married, they're in love, so they're stuck together. So, when I think of inelastic, I think of in love. So, guys, use that to help you remember. So, think inelastic, in love, stuck together. Okay. What? Think about it. What? I know it's kind of weird, but you know how dolls get stuck together. Okay, how would you relate that to inelastic? Okay, you said in love, so yeah, like together. Yeah, in love, inelastic. That's what I'm using. Remember? In love, inelastic. In love, inelastic. Like, so that means, guys, elastic will be the opposite. Elastic will be the opposite of inelastic. So this is a way to remember. This is a good way to remember it. Again, you can come up with your own way. That's how I remember. I think inelastic, in love, together. Now, what were you saying, Shana? Detached and attached and detached. Okay, yes, yeah, you can do that. Yeah, that's a good way to remember it. That's a good way to remember it. All right, everybody got that? Okay. All right. So now, okay, guys, let us get into the equations that you guys need to know for the two types of collisions. Let's start with elastic collision. So let me. Well, no, well, so that in your case, no. So elastic will be they're detached. They don't stick. And so inelastic they attach to each other. But again, I just remember in love, inelastic, and then elastic is the opposite. That's what helps me. Okay, so yeah, in love, inelastic. Yeah, yeah, exactly. All right, guys. So let us get to the math here. So let me write down the equation you guys need to know. Starting off with elastic collisions first. Okay, so let me zoom in here. So, in order to develop the equation for elastic collisions, I want you guys to remember something. Remember what I just said. In any collision, the total momentum of that collision stays conserved or stays the same. So, in other words, the total momentum before the collision is the same thing as the total momentum after the collision. Okay, so that's a fundamental fact. So, in other words, if we have two objects colliding, such as those two carts there that you just saw, so the total momentum of both carts is equal to the momentum of the first cart plus the momentum of the second cart, right? Or the momentum of the first object plus the momentum of the second object. So the total momentum of the first object and the second object before the collision must be equal to the total momentum of the objects after the collision. Okay, so that's just a basic fundamental fact. Um, and guys, remember the equation for momentum. Momentum is mass times velocity. So in other words, the momentum of the first object is m1v1, right? Because P stands for momentum, plus m2v2 before the collision. All of that is equal to the total momentum after the collision, m1v1 plus m2v2. So this right here, this is the equation you're going to use whenever you're dealing with elastic collisions. So y'all got that? I'm gonna pause and let you guys write that down. Those of you guys that are writing. So that's the equation you're going to use for elastic collisions. Anytime you're dealing with a situation involving in elastic collision, you're going to use that equation. Now, guys, what about inelastic collisions? Well, uh, the final equation that I'm going to write here for inelastic collision is going to look slightly different from the elastic collision. But the point is that I want you guys to know the basic principle is the same. The basic principle is the same in that the total momentum before the collision is numerically equal to the total momentum after the collision. So once again, the momentum of the first object plus the momentum of the second object is equal to, yes, is equal to the momentum of the first object plus the momentum of the second object after the collision. So m1v1 plus m2v2. Now that's before the collision. All right, guys, let us think deeply about what's happening after the collision so that we can figure out how this equation is going to look like. Uh, Hold on, guys. Something is wrong with my screen. Okay, there we go. So let's talk about how this equation is going to look like after the collision. Well, let's go back to our cart here, to our two carts. So uh, let's think about this numerically for our inelastic case. So remember, for our inelastic case, because the two carts are in love, they're stuck together. Right? So, so notice, so look carefully before and after the collision. So after the collision, um, both carts stuck together and began moving with a single velocity going in that direction. Okay, so both masses combined. So we're going to need to show that in our equation. How are we going to show that in our equation that after the collision both masses combined for the inelastic case? Well, here's how we're going to show that. So to show that both masses combined, we're going to put M1 and M2 in parentheses, right? Because we're combining both masses pretty much into a single mass. And of course, as they stick together, they move with a single velocity in that direction. So in other words, all of that gets multiplied by the final velocity of the object after the collision. And notice we only have one velocity after the collision, which I'm going to call that the final velocity. And that should be obvious why we're dealing with one velocity, because remember, both masses are stuck together and they're moving at the same speed. So both masses are stuck together and moving at the same speed in that direction. Does that make sense, guys? And I'm going to circle that. So that is the equation you're going to use for inelastic collisions. Okay. All right. Thank you, Angelina, for responding. Okay, so everybody got it? I'm going to let you guys write that down so that you guys can have both those equations. One for your inelastic case and one for your elastic case and one for your inelastic case. So hopefully everybody see the slight difference between the two. So for the inelastic case, we put both masses in parentheses and multiply by a single velocity. Guys, give me a second. Let me go get my door real quick. Yeah, that's fine. Yeah, that's fine. All right, get your Zoom out. Please. All right, guys. Let us get to the assignment and let us just do a couple of problems together. Okay. So now you're going to open up this right here, which says momentum and collisions assignments. We're going to do the first one as a class. Okay. All right, guys. So on this first page here, we have 6 situations, and in each situation, we want to know what is the final velocity of the object after the collision. So that's what we're trying to solve for in each situation. Okay. Guys, before you begin working anything out, you need to first determine what type of collision are we dealing with. Are we dealing with the elastic collision or are we dealing with an inelastic collision? Okay. For example, look at A, guys. If you look at situation A, notice how this ball collides with this ball, and after the collision, notice they appear to be stuck together. Notice how that's different from D, because after the collision, they're both moving, but they're moving as separate objects. Okay, so it should be obvious to you guys which is which. Okay, so let us start with situation A. Okay, so in situation A, again, this ball is moving in this direction. It collides with this ball. And we're asked to find, after both balls collide, how fast are they moving after they collide? In other words, we're trying to find the velocity of the object after they collide. Okay, so that's what we're trying to find. Okay. Can someone tell me in the chat box, for situation A, which equation am I going to use? Am I going to use the first equation or the second equation?
The second one,
Yes, the second one. Jeremiah, why am I using the second
because they're both stuck together in the after.
one? Exactly. Yeah, and the after they're both stuck together. You're exactly right. So we're going to use the second equation. In other words, we're going to use the equation for inelastic collision. So let's write that down. So remember what the second equation says. The second equation says m1v1 plus m2v2 before the collision is equal to, again, m1 plus m2 combined. m1 plus m2 combined. All of that times their final velocity, right? And we're dealing with one velocity at the collision. So in other words, guys, we're trying to solve this equation for the final velocity. So now let's just plug everything in. So let's plug everything in. Let me give myself enough room here. Okay, so before the collision, okay, um, this object has a mass of 2 kilograms, this first object here. And notice how fast it's moving. It's moving at 5.2 meters per second in that direction. So 5.2 meters per second. Guys, let me ask you a question here. If we don't see an arrow here on this object, that means the object is not moving. It's at rest. Can someone tell me what is the momentum of an object that's at rest? Anyone? If it's not moving. Thank you, guys. So its momentum is just zero, right? So m2v2 is just zero, right? It's not moving, so there's no momentum. There's no momentum of the second object before the collision. All of that is equal to, remember, mass 1 is 2 kilograms. Mass 1 is 2 kilograms, and mass 2 is 13 kilograms. So, and of course, all that gets multiplied by the final velocity. Okay, so guys, the rest here, once you plug everything in, the rest is just algebra. So 2 times 5.2 is 10.4. 2 plus 13 is equal to 15. All of that times the final velocity. And guys, what is the last step I need to do? What do I need to do to solve this equation for the final velocity? Yep. Divide both sides by 15. Thank you, Angelina. Divide that side by 15. That goes away. Whatever to one side, I have to do to the other. So guys, when you put in your calculator 10.4 divided by 15, so when I do that, I get a final velocity of 0.693 meters per second. And guys, I really don't care how you round as long as you're close enough to the right answer. I'm good. 0.693 meters per second. Any questions on letter A? Yeah. Yeah, Anthony, that's the exact number. All right. Also, guys, before I let you guys go, well, you know what? I want to say something important here, guys. It's important that you look at the direction of your arrows too whenever you're plugging in your numbers. Like for example, guys, look at situation E. Okay. Guys, look at this arrow. Is someone tell me where's that arrow pointed? So notice this arrow here is pointing to the right, but this arrow here is pointing to the left. So that arrow is pointing to the left, guys. What does that mean? You have to make that velocity what? Anyone tell me? You have to make
Negative.
that yes. You have to make it negative. Thank you. So guys, keep that in mind because remember, momentum can be negative. So please be sure you put your negative velocities wherever you have them. Okay. Um, I'm gonna set up one more problem with you guys. I'm gonna let you guys go. I'm just gonna set it up. Um, look at situation D. Okay. Guys, look at the two balls before the collision, and then look at the two balls after the collision. Which equation am I going to use here? I'm going to use the first equation or the second equation.
The first one.
The first one, exactly, because this is an example of an elastic collision. So for elastic collision, they didn't stick together. You know, as you can see, they're not combined after collision. They appear to be moving with separate velocities. So we're going to use the first one. So the first equation says that m1v1 plus m2v2 before the collision is equal to m1v1 plus m2v2 after the collision. Okay. So guys, if you would just plug everything in. So mass 1 is 10 kilograms. Velocity 1, that's a positive 6 meters per second, right? Mass 2 is 3 kilograms. And that's a positive 3 meters per second. Um, um, after collision, mass 1 is 10 kilograms. Now, guys, we're asked to solve for velocity 1. We don't know what that is. That's what we're trying to solve for. We're trying to find the velocity of the first object after the collision. Like that's what we don't know. Well, but we are given the velocity of the second object after the collision is moving at 9 meters per second. Okay. So, guys, y'all should be able to know how to do algebra and solve this and get v by itself. So I'm gonna let you guys do it on your own. Please be sure you're showing your work. You have to show your work. You have to show me the algebra before I give you guys credit. I'm gonna go ahead and tell you what the answer is, but I still want you guys to work it out to make sure you guys get this. You guys should get V1 after the collision here. It's going to be 4.2 meters per second. But again, I want you guys to prove that to me. I want you guys to show me your work. Such that when you do the algebra, that's what you guys get for letter D. Okay. The rest of these you're going to do by yourselves. Again, you're going to show me your work on letter D like you did on the first one. Now, guys, one of the things I told my third period class, don't worry about doing these word problems here. Where you see these word problems 2, 3, 4, 5, and 6. Don't worry about doing those. I'll probably talk about those on another day. Just worry about getting A through F done. And as soon as you guys get the A through F done, you're going to take a picture of that and you're going to upload that into Schoology. Remember to show me your work. Okay. Someone sent me a private question. They wanted to know how do you choose your equations, guys? Look carefully at the picture. So after the collision, if both objects appear to be stuck together, that means you're going to deal with the first equation. Okay. After the collision, if both objects appear to be separate. No, I'm sorry, guys. I said that wrong. Excuse my bad. Let me say it again. If both objects appear to be stuck together after collision, you're going to use the second equation. However, if both objects appear to be moving separate after the collision, you're going to deal with the first equation. Okay, so got that? So if objects appear to be stuck together, you're going to deal with the second equation. If both objects appear to be separate, you're going to deal with the first equation. And you have your equations here. Hopefully you guys have those equations written down. Any other questions? If you have not filled out the attendance form, please do so. If there are no immediate questions for me, you guys are free to go. Enjoy the rest of your day, everyone.
All right, you too.
All right, take it easy.
All right, you
Bye.
too.
Have a good one, brother.
You too.
Bye, Mr. Taylor.
Bye, Stephanie.
Have a great day.
Bye, Angelina. Have a good day as well.
You too.
Bye, Iman. Enjoy the rest of your day, okay? Have a good one.